Hello friends, how are you? Today we will discuss the nodal equations. A while ago we have already discussed the Maxwell's mesh current from the Maxwell's mesh. We use mainly the current, but for the nodal equations, this is a solution for circuit analysis based on the voltages. So we will use mainly voltages here for our computation for setting up this so-called nodal equations. We will use again the same circuit that we use when we present to you the Maxwell's mesh. As you notice here, there is still currents here, I1, I2, I3, which is the Maxwell's mesh current. Today I will present to you how to get the nodal equation. Let me just consider this node D. We have 4 nodes in this circuit, but for the sake of discussion I will be using this node D. Okay, let me just write here. I will assume a direction of the current from this node will be going out in this branch, and I will name this based on this resistor, which is I1. For DF, my assumption is again going out from that node, and I will name this as I4. So also in DL, assuming again the current to be going there, and based on this resistor I sub 2. But you can have also your assumption. The key here is that you just have to be consistent in what you are doing. I will now get the voltage DH. Solving for DH based on the circuit. DH is actually the voltages of this resistor and this battery. So since the current is going there, we know that this will be positive polarity and it will go out here, negative. So based on the diagram or the sign of the voltages that we use, this is the positive and this one is negative. So the equation will be like this one, equals to this is positive. I just apply here what we have learned already in the Kirchhoff's voltage law. Okay, this one is positive, this is more positive. And this point, we know that I1 multiplied to R1, and the sign of this one, this voltage is positive. This is in the same polarity, no, this battery with this one. So therefore this is plus P sub 1, and we can solve for I1 here using algebraic manipulation. That is B sub DH minus E1, and this will be multiplied to 1 over R1. Okay, for another branch DF, so B sub DF is actually this one. This is again going to this resistor. This is negative, again this is negative, and this is positive. The equation in voltage is I4 times R4, and this one is negative, so this will be negative sub 4. Again, I can solve for my I4 here, and it will give me B sub DF plus E sub 4. Okay, this will be multiplied to 1 over R sub 4, algebraically manipulated. And the last branch here is B sub DL. B sub DL actually equal to, we use the same concept there. So this is I sub 2 times R2, and then plus E sub 2. We get the I sub 2 from this point. So we have the B sub DL minus E sub 2 times 1 over R2. Know how it comes out, just manipulate it algebraically. And then knowing the Kirchhoff's current here at node D, applying the Kirchhoff's current law, since it is all going out, KCL states that the current enters is equals to the current that leaves. We can set up an equation there for currents I sub 1 plus I sub 2 plus I sub 4 is equals to 0. Since the nodal equation is based mainly on voltages, so we will use the values for I1 here, which has a voltage. For I1, you have BDH minus E1. Just substitute BDH minus E1, okay, over 1 over R1 plus I sub 2, which is BDL minus E sub 2, 1 over R2. So that's it. And then I'll just continue to write it here. Plus, maybe I just write here the plus. For I4, for this one, I4 is B sub df minus E sub 2. This is 1 over plus sub 4. It should be E sub 4. This one, 4. 1 over R4. This for I4 then equals then 0. So that's it. This is the equation currents at node D, but we use the voltages. Now we have to get the individual point voltages. Know this concept already. For instance, B sub dH, this is actually equal to B sub D minus B sub H. Therefore, we will just get the point voltage here. Therefore, this will become, so I am now going here just for the sake of clarity. So we are to get the point voltages in this equation. So you have B sub D minus B sub H minus 1. Okay, again this is 1 over R1. I'm showing it to you part by part. So DL is B sub D minus B sub L minus E sub 2, which is 1 over R2. Then I'll again get the point value of the voltage B sub dF, that is sub D minus B sub F and minus E sub 4, that is equivalent to 0. 1 over R4 here is equals to 0. Okay, that's it. So we are going to distribute 1 R1 and 1 over R2 and 1 over R3 to this quantity. So you just multiply, and then you multiply. We won't I think write it we won't write it as is multiplied. You can do that in your notes. Okay, in this case you are going to group 1 R2, 1 over R1, 1 over R2 and 1 over R4. Now if you're going to do that, so you will have this algebraic result: 1R sub 1, 1R 2 plus 1R 4 B sub D. So each of these voltages here, 1R1, 1R2, 1R4 has a B sub D. For 1 over R4, so you'll notice that 1 over R4 you have only sub F, that is subtraction. So 1 over 4, so that is 1 over R4 times B sub F. Okay, then you will also find out that 1 over R1 you have only 1 B sub H there, so B sub H here, and then you have again minus 1 over R2 multiplied to B sub L, so 1 over R2 B sub L, this one, and this is equivalent to the voltages. Now if you will manipulate it, you will have E sub 1 over R1 plus E sub 2 over R2 minus E sub 4 over R4. So this will now be your nodal equation for your node E. So what do you notice? So you notice that a node in which the branches are attached, for example in this case, you have R1, R4 and R2 resistor. So you just add all of that resistor that is attached on this node and invert it inversely proportional of the resistors. You add it and then you multiply it by the voltage at this node D. Okay, for this case, for example for B sub F, so what resistor is attached to that? That is R4. So you take the inverse of that resistor R4 and multiply it to BF, the node here. Okay, and the sign is negative. And for the other node, for example, H, okay, in this branch, what is the attached resistor? R1. So you take the inverse of this one, so 1 over R1 multiplied it by the node here. and the sign is negative. So for the other one, which is L, this node, the attached resistor is R2. You take the inverse of that and multiply it with B sub L, and then the sign is negative, equals the voltages. So you have E1, that is divided by this resistor R1. It is positive because positive is this node is more positive, V sub D, and that's why it is positive. So you write just here positive, and for E2, here E2 also is plus, positive also, and this one is negative, that's why you put it here negative. Okay, E4 over R4. So this is how you set up the nodal equation. Now if you're going to get this one with this tedious solutions or process, it is so hard for you to set up the equations because of this tedious process. But if you know that every node, the system is that you just inverse the node at first and then multiplied it with the node in consideration. Okay, you add the inverse node and multiply it with the node. Then the nodes that is attached, the branch of you consider is negative, inverse of that resistance and multiplied by that node at the voltage at that point, and equal to the voltages over the resistance in which that voltages has. Okay, you take also consideration the polarity, in this case plus, plus, and minus. So the other node like F, like H, and the other node is up to you. So you can right away set up the node. Or just to show to you, for example, I take this one. So right away I can get my nodal equations at node, for example at node H. Node H, my nodal equation is, so what are my resistances? You have R1, R5, and R3. So I just have to say 1 over R1 plus 1 over R5, 1 over 3. So I will multiply this to the voltage H, V sub H. Okay? What are the other nodes? Consideration, you have B sub D. So B sub D, what is the resistance here? R1. So that is negative 1 over R1 times B sub D. Simple as that. So what is the other node? This branch. So this is node F. No, that is negative 1 over R5 multiplied by B sub F, and you have negative 1 over 3. This is B sub L. Okay, equals, you have E1, and since that this is opposing, this is positive, assumed to be positive, so this is negative, so that will be negative. So E sub 1 all over the resistance at that branch, which is R1, and here also is negative. You have E sub 2, and the resistance there is R5, and another one is negative also, so that is E sub 3 R3. Okay, so this is now the nodal equation at node E. So you get the other nodal equation from this node F and also L if you want. Okay, so this is all about nodal equation. Thank you.